So now let's talk about combining like terms. So I think maybe the easiest way to start this off is to just give some examples of like terms and some examples of unlike terms. Okay. So some like terms, what we're looking for here is that we have the two terms will have identical variable parts. Okay. So I guess before we even do this, we have a couple things we should look at here. Okay. We should look at the two parts of a number when we have some kind of linear expression. Okay, so let's say we're given ax. Okay, or better yet, let's do 4x. Be more specific here. We have 4x. Okay, so if we have 4x here, all right, this is going to be the coefficient. Okay. The 4 is going to be the coefficient, and the x is going to be the variable, okay? And let's say we have 3x to the third, okay? 3 is going to be the coefficient, and the x to the third, the whole thing, is going to be the variable part, okay? This is also the variable part. But x is the variable in both cases, but the whole part, x to the third, is the variable part. So you can really split up these sorts of numbers into two parts, all right? We have the coefficient and the variable part, okay? So let's take a look at some examples of like and unlike terms given this, okay? So let's say we have 5y and 12y. These would be like, okay? And they're like because they have identical variable terms. Their variable parts are identical, okay? Both y, okay? But let's say we had 5y squared and 12y. These would not be like, okay? They would not be like because the variable part is not the same, okay? Here we have a y squared and a y, so they would be unlike, okay? How about 3x squared and 2x squared? Okay, these would be like because they have identical variable parts, okay? And then maybe unlike would be maybe just 3 and 6x squared, okay? Or maybe one doesn't even have a variable part, okay? The 3 does not even have a variable part, and then we have 6x squared. So really what we're looking for here is we want an identical variable part. If they don't have an identical variable part, they are not like. And what's really nice is if we have identical variable parts, if we have like terms, we're able to combine those terms in a linear expression into one term. Okay, so let's take a look at this first example we have here. We have negative 2x squared minus 10x squared. So if we have like terms here, if we have identical variable parts, we can go ahead and add or subtract these together. Okay, so here we see x squared and x squared, so these are like terms. Okay, and so this looks like just all we have to do is we have to worry about the coefficients here. Okay, so this is the same thing as adding, we're subtracting negative 10x squared from negative 2x squared. So really, we're just going to worry about the coefficient part where we subtract 10 from negative 2. And then we're going to bring the variable part along with it. So this is going to be the same thing as negative 12x squared. Okay, you can combine them into one, so to speak. Okay, you could also think of this in terms of the distributive property as well. Right? You could think of this as, if this is confusing to you, you don't necessarily have to think of it this way. But you could think of this as negative 2 minus 10 times x squared, where we're kind of undoing the distributive property, okay? But in either case, we get negative 12x squared. Okay? Let's take a look at 5u minus 8u. Okay, well, again, here they have like terms, okay? So we can go ahead and combine them. And so this is really the same thing as 5 minus 8, and we're going to just carry the variable along with it. So this is going to give us negative 3u. Okay, here's a little bit more complicated of an example. Here we have 4x squared plus 2x plus 3x squared plus x. Okay, so here we're going to start by trying to find all of the terms that have that are like. We're going to try to find all of the like terms. We're going to try to combine them all. Okay, as much as we can at least. Okay, so here we see 4x squared. So we're going to look at all the other terms and see if we can find any other x squareds. So we have an x squared here and an x squared here. So we're actually able to go ahead and combine those two terms into one. So if we have 4x squared plus 3x squared, okay, 4x squared plus 3x squared, that's going to give us 7x squared. Okay, and then we have plus 2x plus x. And we'll also see that the 2x and the x they're going to have identical variable parts, so we can go ahead and combine them as well. Well, this is actually the same thing as 7x squared plus 2x plus 1 times x. Okay, so if you don't see a coefficient out front, it's an implied 1. Okay, so we can actually think of this as adding 2 to 1. So we're going to get 7x squared plus 3x. Okay. Now let's take a look at this one. Here we have 5x to the third plus 2x squared plus x plus 3x plus 4x to the third plus 2 plus 7x plus 1. It's a little obnoxious, but it's done on purpose. So, okay, here we have the first term here is 5x to the third. So let's see if we have any other terms that have an x to the third. Looks like we just have one, and that's 4x to the third here. So we can go ahead and combine those two together. So this is going to give us we can go ahead and combine those two, and we're going to end up with 9x to the third, because 5 plus 4 is 9. Okay, let's take a look at the next one. We have 2x squared. Okay, let's see if we have any other x squared terms. X, 2, so no other, there's going to be no other x squared terms, so we're just going to leave that one alone. We have 2x squared. Okay, then we have x. So let's see if we can find any other x terms. So we have x, we have 3x, and we have 7x. So we can go ahead and combine all of those together. So remember, this is the same thing as, this one here is the same thing as 1x. So we'll have 1x plus 3x plus 7x. So that's going to give us 11x. Okay? We already did the 4x to the third here, and now we just have this 2. So this is our constant term here, so there's no variable part to it. Let's see if there's any other numbers that are like that. We just have the 1 here. So we can combine those together, and we're going to end up with 2 plus 1, which is 3. So this whole thing simplifies to 9x to the third plus 2x squared plus 11x plus 3.